Yeah, so those who say rendering is easy have never actually implemented rendering in any particular way using raw OpenGL. So the goal right now I'm trying to do, and I'm slowly building up steps towards this, is all I want to do is render a bow tie on the head of the creeper. Don't ask why. It's a really stupid reason, but it's like, you think it'll be simple. And there really is a simple way to this. I literally could just edit the creeper model and add a bow tie to the top of the head. But my brain's like, yeah, let's go ahead and implement a generic render that I can render anything on any creature's head, any position on the head, like the sides of the head, the top of the head, the front of the head, whatever, it does not matter. And then you start implementing code, and it's been a nightmare and a half to implement this. And the current iteration, just, yeah. We now end up with this situation where, and we're using dispenser by the way because it just has a front to it. I can see where the front is. But yeah, this creeper, if we can get it to rotate. There we go. Basically, we now end up with a situation where this is going to rotate anywhere and everywhere as it moves. And this has to do with kind of how the code's implemented. So for the people who've never used Roll Up in GL, you basically get translate calls and rotate calls and scale calls. You get 3 different types of calls you can run to manipulate the object. And the way you're supposed to do this is you're supposed to translate it, then you're supposed to rotate it, scale it, so on. There's different orders to things you want to do. Now, if we translate it first and rotate it, it works just fine. You get a render position that is really close to the enemy, just not spot on. The big problem I'm really having issues with is I'm trying to render blocks, and blocks render position is at bottom corner right there. So that corner needs to be in such a spot that when I rotate this, it ends up in an appropriate position. And there are ways to fix this, like you can translate it, then rotate it, then translate it again, and it should get somewhere close. And there's been a couple examples, like I go through the Dropbox here, I've gotten really, really close to rendering things perfectly. Like this is an earlier example when I was messing with the layer system. There's a system that you can supposedly you're supposed to use called a layer system. Is how a lot of different effects Minecraft is implemented in the newer versions is actually done. For example, like the actual charged creeper skin that you see on creepers is done via a layer system. The only difference here is rather than it actually doing a whole bunch of translation rotation calls, it quite literally is just rendering a second copy of the creeper model with a different texture, which is really easy to do. Layer system is very effective for this if you want to do quick texture switch outs. For example, when we render a saddle on a pig, that is a really easy system. For example, we go down here to the mirror pig, which is that aquatic fish pig thing I made. The way that the rendering is actually done on that, if I can find it here, is there's a little thing called a layer saddle mirror pig. And this literally uses the pig model and renders it with a different texture and renders it just with that saddle. Pretty straightforward. Layer system is really cool for this. I don't know a huge amount about the layer system, hence why probably I'm having as much difficulty as I really am. Was having much difficulty with it as I was because I now switched back to doing an old school way. The old school way when you used to do this back in older version of Minecraft is you just took inside the render method. It didn't matter really where it was. There's actually several different render calls that are called. If you do it in do render and you specially do it after this one, it removes a lot of the translation rotation calls that are applied to the entity, so you don't have to really mess with those. That's probably the biggest reason I was having a problem with the layer systems. I'm having to deal with a ton of extra rotations, which was causing the render position when I was working on it to be on the top right position of the head right here, which was not really working because what I really want the render position to be for if I'm rendering stuff on the head is actually to be where the neck is. So if you see the creeper head and it rotates up and down, its render position is right there on the top of the body, so that the reason when it rotates like this, there isn't a lot of code involved in the process. It actually just rotates really smoothly and works, but now I'm trying to get stuff to work effectively in that process, and it's just not cutting it out. And there's probably some code I'm missing here, and there's probably stuff that Minecraft does that I really should spend more time looking at in order to get it to where I need it. And there are probably ways I can get this close. Like for example, I'm noticing one thing with this is we're getting a bit of an inverted yaw rotation. Actually, this is the front of it right now when it comes to the rotation point, or it was. This is one of the more confusing parts about this. I think maybe if I invert the yaw rotation here, and we're using the actual model's position for it, which it really shouldn't be using because I should be actually using the head properties and it probably would work a little better. But theoretically, I can use the model rotation points. It should give me the current rendered model, because everything's rendered one after another, so I shouldn't be getting values from another entity. And that actually has improved the situation just a little bit. It's still not perfect. Yeah, we're definitely getting some weirdness with this. Now, yeah, it's at least rendering facing the right direction now. Unfortunately, now the pitch is going to tilt it left and right, which is not really working. I could switch the roll. So one of the tricks I could do for this is instead of using x-axis as my pitch, I could use the z-axis, and that would get me something relatively close. Unfortunately, now we're on this side of this block, so come over here, face this way. Yeah, this makes it even worse as this creeper is not being cooperative. That is giving me a little bit better of a result. So if I could definitely fix the rotation, it would actually work. And the way we could fix the rotation, and this would be real easy to do, well, actually this would not be easy to do, is we would have to force the entity's head rotation to, so if we did rotation yaw equals 0, and then entity.head rotation equals 0. And that should force the entity to face, I believe, north. Wow, it would actually work if this actually was running the way it's supposed to. I think I need to set the previous as well. Entity, because there's actually some checks to make it work smoother. So you've got actually previous rotation on the head, and then you also got entity.previous rotation on if we reset that. That should have worked in, yeah, here we go. So now this creeper is going to always face north. Theoretically. South, apparently, in this version. It's still trying to move, even though theoretically it should actually be forced to a certain position. Oh yeah, because we still have pitch direction, and you can see the body is still trying to attempt to move, but it's not quite working. And as soon as I said that, it starts walking away. And the body rotates. Uncooperative code is a really good way to put this. So at least we got it in a decent direction. So now we can sit here and we can use that to kind of figure out what we're doing with the code here. And what I'm going to say is I need to flip the pitch back to the other axis, because we are getting it really, really close to where I need it. Okay, so if I go up, will you actually stare at me? You know, when I usually do missile renders and stuff, I actually end up having to force stuff to actually be in places, which I think I'm going to have to do with these creepers as well. So what we're going to do is also mess with this pitch on the head. So, pitch. And how it works for Minecraft is the rotation pitch is actually the head's rotation pitch, because the body cannot actually pitch. So you'll see that as being just called pitch. And this has to do with not that Mojang called it this way. This is entirely because MCP, which is a system we use to decompile the game and turn it into something usable, somebody came in and went, oh, that's pitch, that's yaw. And they're kind of right, because entities are meant to be generic, so they pitch and yaw is that way. And it just happens to be that Minecraft uses that as a pitch. Although it would be kind of nice if there was actually a variable called head pitch and you could use them separately, but there's actually not a system for that. So you end up actually have to implement your own head pitch. Your body should still not be able to rotate. Actually, why do I even care about the body? It's the head I care about. So cool. So we got this set to 0, so that's working. Now let's see if we set it to 45, what happens. That's going to point down. So our pitch is working. It's pointing up and down accordingly. Now the real trick is trying to figure out how to get that yaw to work appropriately. So let's remove the negative in front of this. This is, by the way, not meant to be a follow-along tutorial. I'm just trying to show off some of the difficulties of working with OpenGL, especially when you're not used to it. I'm definitely not a render wizard, which is making this extra difficult. So now let's set our head position to 45 as well. And that'll give us an opportunity to figure out if our yaw is matching as expected. So we got to keep in mind that that side right there is our front. What's kind of weird is the body's rotating, and our cube is rotating with it. But we don't actually have... No, that makes sense, because we're using the head rotation angles from the model. The model would have been previously rotated by the above code. So when you do super render, it actually renders the model. It goes through a whole bunch of steps. Like if we go through here, it'll go up into super and does a huge amount of code to do all the cool stuff and make it render. There's a lot of stuff in there. I could spend all day documenting that and just explaining how it works. So that would, in theory, yeah, we would be affected by the body rotation. But the weird thing is the body rotation should be set to 0 before the next method call triggers over, yet it's not actually being set that way. What we could do is force the rotation angles in the head. These are actually stored as radians, so it makes it actually a little bit difficult to deal with. But it would actually solve a few of our problems, because then we wouldn't have to deal with the entity rotations changing on us. We would actually have direct control of the rotation value that we're actually pulling data from. This wouldn't really actually work, I'm thinking about it, because then we wouldn't be able to track how the rotation of the actual head is being behaved. Because what we want to do is we want to get this to match that blue line right there. And yeah, that's our side, so our rotation is being weird. It could be because we're turning this into a 180. Well, actually, this is the equation how you convert stuff from radians to degrees. It's times that. Yeah, it doesn't matter. So let's go back to the negative thing and see if that gives us a little bit better results. Kinda. What we're actually ending up with is an inverted value, which is what I didn't want to happen. This is a really big issue that I've had with missile renders in the past, is that if you try to fix certain issues with this, you end up with really strange results. Definitely being weird. Like, the head's matching our expectations right now, but then we're getting rotation off of everything else. But we shouldn't be getting any rotation code down here, because this is the exact feed-in for the entire rotation loop. I mean, I could probably tell the entity to completely stop moving, and that would solve a ton of problems. Because then the entity would spawn out, I had full control of it. It's definitely trying to face me now. As you can see, the body trying to rotate. And that cube, so that side right there should be our direction facing. It's working, and the pitch is correct. But we're not getting that yaw correct, because the body's trying to rotate, or the cube is trying to rotate with the body, which doesn't make any sense. Because all of this should be set to 0. Let's dig through the code here. You get all this code right here. So this is where you see the previous yaw, and they basically interpole between the two of them, so that way you can't have an instantaneous head snap. You get a much smoother head rotation, which looks really good. And then previous, well, these are actually stored on both sides, but it ends up doing that. No need to worry about that code. And this is where you get render living out. This is where the translation call is done. Go back to here and go back up in here, because all the stuff is done in render living base. So this is a code that actually renders almost every entity in the game, short of a couple. And you get the apply rotations, and the apply rotations, you got a depth thing here, and then of course you got some hidden features for certain developers. And here we see rotation yaw being applied. So this stuff should turn off, but we do see that the rotation yaw is being done by 180. So maybe this is our solution. This actually might be it too, the missing component. That's the reason why it's always nice to go through and actually read Minecraft code, because you'll find the missing stuff that you were looking for. Yeah, we'll do it that way, because that might give us what we're looking for. Ooh, interesting results. Move the entire position of the cube, which is... How would a rotation value mess our position so much? Because we're not actually applying position anywhere else. Our only position is right here, which we're trying to center the model in such a way that when we do start rotating it, it's rotated enough that we shouldn't see movement. That is weird. So I'm going to say one way to fix this is I'm going to get rid of relying on the actual model rotation parts, and what we're going to do is do a math.toRadians, and we're actually going to start pulling the entity's rotation points, because the main reason I wanted to use the head model parts is it does result in a little bit better functionality, because you're actually using the very part of the render that you do want to rely on for the actual system. The downside of using the actual rotation values is they could be off by just enough of a part that it makes the model not look as clean. But then again, this is Minecraft and nobody's really going to pay attention, especially since you're probably more likely to run away from these entities rather than actually care what's happening. There we go. That actually gets us a better snap on where the head is. So that fixes that problem. So that lets us give more control over this situation. What we're going to need to do is I'm going to need to translate this again. I don't know if it's a really bright idea to translate after you've actually moved it once. Still a novice when it comes to OpenGL. Like, I know how to use it, I know how to render stuff in it, I even know how to use it outside of Minecraft to some extent, but I still haven't figured out the nuances and the kind of niche cases of how a lot of this sub stuff works, because to be honest, I'd rather rely on the library for all this. Okay, so that's getting some results there. Looks like we're going to want to move it by actually 5, which doesn't make much sense because we plussed it by 5 over here and we're plussing it by 5 again. But if that gets us, that doesn't get us anywhere close. Maybe I don't need the Z direction. The Z would be depth. I think we were good on depth. Or we need -5 on the depth. This is another trick with this, is that you have to mess with this a lot. And this is going to be even weirder. And actually, was I close the first time? No, it's... Maybe I don't need to mess with the X direction at all. Maybe it was close enough. Yeah, we were pretty close. But another thing I was about to say before I was messing around with this is that when I go to scale this down to make this smaller, it's going to break like everything. And I'll show this really simply, is that I have a scale call down here that should, in theory, if I was not missing a value, I'll put the original values back in here. This was originally inverted because I think blocks render upside down on entities. Just how Minecraft is designed. Yeah, so as soon as I scaled that down, it just moved our entire model on us. And this is going to cause all the translate calls to be different, because how OpenGL works, and I'm going to leave off on this because I don't need to make this video to be 40 minutes long of me messing with stuff. But how OpenGL works is when you're making all these calls, you're moving the plane of render. So a good way to put this is I open up Paint, because Paint is just real easy to visualize it because I don't have to write any code to actually make things. You have this plane of render. So this is your plane, and say you had an object which is right here in the middle. That's the object you're going to render, and it hasn't been moved at all. When you actually call translate, you're moving the entire plane of render. And you're moving it up, you're moving it down, you're moving it wherever. When you rotate the entire thing, which I don't think I can even do in Paint, you actually rotate the entire plane of render. You're not rotating the model. That's not how this works. OpenGL works on the system that you're kind of moving the render bounds or our system. I don't know exactly how it's called. Once again, not an expert on this, but you're moving all that stuff around. So when you rotate, you move the entire plane. When you translate, you move the entire plane. When you scale the entire plane down. So that's the reason why the translate calls change, because in OpenGL's mind, you didn't actually move it at all when you scaled it down. So a distance of 1 is still a distance of 1. What changed was the size of the box, more or less is the way to think about it. So now one distance is half a distance in the box equivalent if you scale it down by 2. But still the calls are still 1. So if you translate by 1, you're still moving 1 inside the bound box, but in the actual render perspective, you're moving half the distance. It's a really confusing thing to think of, and it actually gets even more confusing. Like, say for example, you want to make something twice as wide but same height wise, you're going to throw a lot of your stuff off. Good thing is all of this is done per axis. You have an X, Y, and Z axis, so if you scale something in certain axes, you just have to like double your values, and there is a lot of mathematics you can apply to make your life just so much easier with this. And this is the reason why those who probably spotted this, I actually have some sine cosine calls here. Is the plan is, once I figured out where this render position is, where I get it the box rendering perfectly on the head where I want it, I can then make that box move. So that way, in this case, I want to render a bow tie on the corner here. I want to get it so that way the box would render perfectly and rotate perfectly, so that way it's basically the same size as the head, and then I just have to move it down to the corner, and then I'm done. I got it rendered exactly where I want it. And I can save all the code for that, and I can make more code to do things like render ears, hats, whatever, and work on that. But I'll leave you guys here, and see you guys later with more content and videos.